Hello, and today we are going to synthesize 2-chloro 2-methylbutane. So, first thing you wanted to do, set up your separatory funnel in a stand and make sure your stop clock is closed. And the first thing you're going to do is take 10 mils of the tert-amyl alcohol and add it into your separatory funnel. Once you have that done, then you're going to take 25 mils of concentrated 12 molar hydrochloric acid solution and dump that in there as well. And once you have those in there, then what you're going to do is just stir it with your stir rod for a minute, something like that, just to get everything mixed up, since there will be a little bit of gas evolution in this reaction going. So after stirring it for a bit, you can see there are now two layers there, bottom layer and top layer. The top layer will be your new product that is forming. So next what we're going to do is just put your stopper on there. You're going to kind of shake it back and forth, but the moment you invert it, you're going to want to degas it because there will be lots of gas evolution. And you'll do this for about 5 minutes and just keep venting it the whole time that you're doing it. After 5 minutes or so, you're now just going to leave it to separate. You can see there's two layers, but there's a bit of a kind of a mixture there, so give it a minute or two to separate. And in the meantime, you can grab your 250 Erlenmeyer flask, set it up, because this is where all of our aqueous layer is going to go that doesn't contain our product. So now that we have two distinct layers, we're going to drain this bottom layer, which is our aqueous layer. So this is everything that we don't want. Then next, what you're going to do is you're going to add 20 mils of saturated sodium chloride solution, or another name for it is called brine. And what this does is removes the water from our solution, as there still will be a little bit of residual water, as that's one of the byproducts from our reaction. And you can see there's two layers that formed. So now what you're going to do is just shake it back and forth like we did before, and then let it separate to its layers. So now that we have that done, you can see our bottom layer we're going to discard. That's our aqueous layer. It will have removed any excess water from there, and our top layer is our product. So we'll drain that all out and keep that top layer. So we have that all drained out. Next step, we are going to take saturated sodium bicarb solution. Now, this is another wash. It's supposed to neutralize any acid that's in there. So once you pour your 20 mils in, you're going to stir it a bit, just with a stir rod, because it will produce a lot of gas, a lot of CO2. You'll do this for about a minute, and then once you're done, you'll shake it, or stir it back and forth with a stopper on, just like we did with the previous two steps. When you're doing this, just be sure to vent it a lot, because there will be CO2s produced, and you don't want it to pop the stop off and make your product go everywhere. So once we've done this several times, you can see we got our two distinct bilayers again. The bottom layer is our sodium bicarb layer. That's everything we don't want, so we're just going to drain that out. And we want to keep our top layer since that's our organic layer. Now we've removed all the acid, and what we're going to do is one more wash with the saturated sodium chloride, and that's just to remove any more residual water that may have been brought in from the sodium bicarb. So pour that in. Let's see, the two distinct layers again, and then we're just gonna shake it again and be sure to vent it and do that several times, and then drain the bottom layer. So you can see we got two distinct layers there. So the bottom layer, the saturated sodium chloride, I'll drain that out. And there we go. So next what we have to do is drain this into our little Erlenmeyer flask. So adjust this, move it down so it doesn't spill. And then you're going to drain it all into there. So we can move our standard separatory phenolate out of the way. So now we have our product in here. Now what we're going to do is add calcium chloride. This is a drying agent. So we'll just add like a small scoop in there. Didn't get enough the first time. And this will remove any residual water we didn't get in the washes. So once you add that, then you leave it for about 10 minutes just to dry. So in the meantime, while this is waiting and drying, we can set up our distillation apparatus that we're going to use for the next step. Also, be sure to get the weight of your 25 ml round bottom flask. Otherwise, you're not going to know what your yield is. So after 10 minutes waiting, our solution here, we are going to transfer it to our 50 ml round bottom flask that we're going to reflex out of, or sorry, distill out of. And we're just going to use a pasture pipette, suck it out, and put it into the 50 ml round bottom flask. You don't want to absorb or suck up any of the calcium chloride. You'll just do this with all of it. And there we go. Now, you're setting this up. You're going to put your round bottom flask in there. You're going to put some sand all around here. This kind of acts like a thermal sink for it. Keeps it more evenly. And there we go. Our distillation is set up, and now we're good to go. So once we have it set up, we have our water on. Remember, you'll only need very low pressure water. You're gonna turn your element on. Your rheostat's gonna be set to 40, and then you are going to wait and record the temperature at whatever the max it is that it reaches. And then as soon as it starts to drop or increase sharply, then you shut it off and record that temperature. The temperature we're looking for roughly is between 81 and 86 degrees. If you need a review on how to set this up, go review the distillation lab and check how all the hoses are set up, and you'll be good. So now that it's distilling, temperature has gone up to 81 degrees, so that indicates our product is distilling off. So the temperature started to drop, just removed it from the heat. As soon as it's done, leave it set up until it's cool enough that you can touch it with your hand and not burn yourself, and then just wait from there. All right, so after cooling, this is our product that we ended up with. I ended up with a boiling point of about 81 degrees, which is in literature value. And now you're going to have to go weigh this. Make sure you dry all the water off of it, otherwise you'll get a false weight. And after weighing it and doing the math, I ended up with a 77.8% yield, which is okay. And there's still something, you can see it, there's still a little bit that's left in there, which is good, because that'll be either water, starting material, or something else, so that's good. So, and then once you're all finished, you can take everything apart, clean it, and dispose of your product in the chlorinated or halogenated waste. And your aqueous layer back here, this can be neutralized with sodium bicarb to a pH of 7, and then you can dispose of it down the drain, and then you are all finished.